So during these lecture sessions on MRP, we'll take up a number of numerical examples. But prior to the discussing these numerical examples, so let me just again refer to the MRP outputs. Okay, so in the past the lecture sessions, in the previous lecture sessions, you have come across, you have seen this diagram or this figure. So here what we have specified, that means the planned say material requirements planning, MRP systems. So it is basically designed with three kinds of inputs you are already aware of. One is the MPS, the second one is the product structure code, and the third one is the inventory status. So these are the three inputs, and these three inputs are creating the material requirements planning system. And what is the basic output? The basic output of material requirements planning, or the MRP, is the planned order releases. Now these planned order releases can be of three types. First one is the purchase orders. That means how many units or how much you are going to get from the suppliers, and so you need to procure from outside, and that's why you need to raise a purchase order. The second one is the certain portion of the quantity is required, a portion you plan to produce in-house, and for producing in-house that quantity what you require, you need to place an work order, say to your fabrication shop or to your assembly units, to your machine shop. So you need to place an work orders. So how much quantity are under work orders, so that must be known. And then what you try to do, now you constantly monitor the situation. So these are basically the work orders you are placing. Now you are monitoring the lead time, and as the time passes the situation changes, and as per the change situations or the change conditions, many a time you need to go for making them aware, or the sending notices to the concerned persons or the concerned group or the concerned work units or the concerned suppliers. So these aspect is referred to as reschedule notices. That means you need to replan the whole thing. That means as the time passes. Okay, so these aspect you just keep in mind. And then as far as the outputs of the MRP system is concerned, it is an online real-time system, control system. Now what actually you are controlling, which aspects? So this is a standard format in any MRP system, and what we try to explain, that is what are the parameters you need to control all the time on the online real-time basis. Now this the parameters, you should, the values of these parameters you constantly monitor over the time, over the time buckets, and over the planning horizon for each dependent item. So what are these? First one is the gross requirements. Okay, so this information you must have. What is the second one? Second one is the scheduled receipts. That means you have say production unit, and you have a supplier for the given item. You have production unit, you have a supplier. For the supplier, from the supplier, so you are supposed to get these items on a particular date. And similarly, from say the work orders which you have placed to your say the own systems, own manufacturing plant, So again you expect actually that at what point in time you will be getting see these work orders. So with this information you have these the scheduled receipts, say the data. Then the projected on hand, that means you have that inventory control system. That means there is always some inventory transactions like issues, like receipts and the balance. So what is the balance amount on a particular day, at the start of the day? So this is the projected, this is that and based on your the normal consumption rates or use rate, can you project this amount? That means the projected on hand. That means suppose this is the first day of say the first week, and you have say on hand inventory of a particular item. Now can you predict, so what could be the on hand inventory on the first day of the following week or the next week for the same item? So obviously there will be some assumptions, and so for each item the projected on hand, say the inventory level, so you must be able to calculate, and we will calculate this in fact. Then the net requirements, and these net requirements, that means projected on hand, the scheduled receipts and projected on hand. So if you subtract from the gross requirements, then you get the net requirements. And once the net requirements is known as of now, then either you place an order to a supplier, or you place the work order to your in-house facilities. So you have this data, planned order receipts and planned order releases. Is it okay? So these are the 6 important parameters always you try to monitor in this online real-time control system. So obviously you will find that these inventory related parameters primarily are the dependent on the production related parameters. So we have already discussed the inventory management systems, the several the kinds of say the systems we have already discussed, and during those lecture sessions on inventory management systems, what we have assumed that primarily that inventory systems is existing independently, right? So the procurement function can act independently. That means it has several the features which are the unique, and say the inventory model is primarily the decided by the procurement function. But here when we extend your say your concepts to say the dependent demand items, then you come to know that how much say the dependent you are on the controlling the inventory of dependent demand items on the production control systems. And that's why the MRP system is created. MRP, it is original versions or say the new versions or updated versions, whatever it is. So essentially it represents both inventory control as well as the production control systems. Now here is an example. So now what we'll be explaining say all the aspects of certain numerical the problems which we have taken up. Suppose, so this is example 1, numerical example 1. Suppose 100 units of product A must be available in period T. Now the measuring units could be week, that means on 8th week. in period 8. So the period 1, period 2, period 3, say each one period represents 1 week like this. So in period 8, if no stock is on hand or on order, that means the starting point or the initial condition is 0 inventory. Determine when to release orders for each component shown in figure. Now what is this figure? This figure actually is a simple representation of the bill of material. And what you need to do, you need to also determine the size of each order. So order for which item? So the order for say B, C, D, E. That means in order to say produce the end item capital E, A, what do you require as per the bill of material? You require item B and item C. And to produce 1 unit of capital A, you need 1 unit of B and 2 units of C. Okay, so this is the first level. So this is level 0 and this is level 1. Now this may be the sub assemblies, this may be the sub assemblies, or this could be a component, C also could be a component, or this could be item B could be a sub assembly and item C could be a component. Okay, so depending on which particular product you have designed. So given a particular product, you will have this specific information. Now in order to manufacture C, what you require? You require say item D and item E, and in order to produce say 1 unit of C, what you require? You need 1 unit of D and 2 units of E. So this information you collect from the bill of material. That means you must go to the design department and get this data. That means what you are trying to do? That means I am creating an inventory control systems primarily, but I am linking it with the design department, and first I link it to the design department. That's why the bill of material. Next what I will do? I will link it with the master production schedule, and so obviously I am linking my inventory control systems to the manufacturing systems or the production system. So how many levels you have? Level 0, level 1, level 2. Now what is this LT? LT stands for the lead time information. That means the lead time for item D is 1 week or the time unit, and for item E it is also 1. For item B it is the 3 time periods, 3 weeks or 3 days, and item C the lead time is 2, and for item A the lead time is 4. So this is the data we have. Now if no stock is on hand or on order, determine when to release orders for each component. Okay, so this is shown in figure. So this is, I hope that you understood the problem, and the size of the each order you need to determine. Product A is made from components B and C. C is made from components D and E. This point already I have elaborated. By simple computation, I have already mentioned that that MRP calculation is essentially a simple arithmetic calculation. So by simple computation, the quantity requirements for each component are as follows. The component B, that means 1, the number of A's equals to 1 into 100, that is 100 units. Component C is 2, that is number of A's, that is 2 into 100, that is 200. Component D, that is 1, the number of A's is 1 into 200. Obviously component D and E is dependent on component C. So you need 1 unit of say to produce, so it must be multiplied with say the 200, say 1, and this is 2, that is 400. It's clear? So the 100 units you need to produce, that means for which, so if you refer to this one, that means this is 1. That means 100 units if you want to produce, you need 100 units of B and 200 units of C. And against say the C, that means it is 200 units of D you require, and this is 2, that means 400 units of E. So exactly, so 100, 200, 200 and 400. Is it okay? In order to produce 100 units of product A, that is the final assembly or the end item. Now what you do, MRP, you make a plan, that means MRP plan for 100 units of product A in period 8. Is it okay? So what you require, that means your lead time is 4 weeks. As you just referred to the figure, you will find that against A, the lead time is mentioned as 4. Okay, 4 time periods or 4 weeks. So you need this item at time period 8. That means the gross requirements is 800. Now what is your lead time? That means the planned order releases. That means just 4 weeks before the eighth week, you need to release the orders. So on 4th time period, that means suppose each so the time unit is week, that means this is the 8th week and this is the 4th week. As the lead time is 4, so you need to have the planned order releases on 4th week and the amount is 100. Now you explode, what you try to do, explode, that means you need, say for producing say 100 units of A, you require 100 units of B items, and for B items there is a lead time of 3 weeks. So obviously if you want to have say 100 units on week 4 or time period 4, that means these 100 units you must get, 100 units of B you must get on the 4th week. But for this item you have a 3 lead time period. Is it okay? So 3 weeks. So on the 1st week, that means this is the 3rd week, you backtrack. So you need 100 units of B, okay, to be ordered in the 1st week for item B. So your gross requirements for item B is 100 on the 4th week, and your planned order release is 100 units on the 1st week. It's clear? Now in order to produce say the end item capital A, you require the 2 units of item C. So obviously you require at the same point in time, that is on 4th week or the 4th time period, you need 200 units of item C, and for item C the lead time is 2 weeks. So I am explaining it very slow so that your understanding is appropriate, and you will come to know say the all the intricacies of say the MRP systems and how does it work, okay, and how do you do the computations for different the parameters in an MRP systems. So the 200 units you require at the 4th time period, and you have the 2 lead times. So in the second the week or the 2nd time period, you have a planned order releases of 200 units. So this is the gross requirements on the 4th week. Is it clear? Now the next what you do, you go for the item C. Is it okay? So item C 200 units require. Now this item C consists of 2 parts, item D and item E, as per the bill of material, say the bill of material document. So now you need to produce 1 unit of say the C, you require 1 unit of D, and the 2 units of E. So that is as per the bill of materials. So for the 200 units of C, you require the 200 units of D. So that is the gross requirements. And what is the lead time? Lead time is 1 week. Hence, there will be planned order release on, or say during the first week or the first time period. Okay, and to produce say 1 unit of C, you require 2 units of E, capital E. So for producing 200 units of C, you require 400 units of E, and for item E you have 1 week or 1 time period, the lead time is 1 time unit. So that's why the planned order releases will be made on the first week, and the total total requirement will be 400 units. So this way you make the plan. So this is your this document you prepare, and as the time passes, okay, like say this is at time t equals to 0, you make this plan. Now after say 1 week or 1 time period, you check the current situations for all the items, and accordingly you make a plan. So if the time bucket is say 1 week or say 1 day, that means every week once or every day once you have to take stock of the situation, and the gross requirements against a particular item must be calculated, that is already known, and the planned order releases. Okay, so you recalculate or constantly you update these values. Is it okay? Now once you this is the first step, but we have not completed all the steps in an MRP calculations, because what you need to do, that is that the order releases. Now so the order will be placed. Now this order could be in the form of work order, or this the order could be in the form of purchase orders. So again when you place the order, so there will be a lead time for both work orders as well as the purchase orders. So again you have to go further down, and you need to constantly monitor say the current situations, and with respect to the work order, say the work order, and with respect to say the purchase orders. So the inventory levels so is constantly, and accordingly their effects on the inventory levels of a given item. So for the next example, we are moving to the next example, that is also say a representative numerical examples in respect of MRP. So for the MRP, the table below, is it okay? I have already mentioned that these are the items, or these are the parameters in a given so the MRP document, and you need to constantly monitor the values of these parameters as the time passes. So I refer to the next example, that is for the MRP table below, indicate the project on hand, the planned order receipts, and the planned order release. The lead time is 2 periods, and the lot size is the same as the net requirements. That means here the lot size is equals to 1. Okay. Now what you have this table. Okay, so this is the planned or the projected demand, and how many the periods you have considered, that is 1, 2, 3, 4, 5, 6, 7, 8. So 8 time periods you have considered. So against each period you have the gross requirements 5, 10, 18, 0, 10, 6, 0, 14. Now here just one point you make a note, like many such the products these days, you will find on the end items, you will find that the demand is the demand is highly erratic. That means it doesn't follow any pattern, and it is anybody's guess. So what will be the demand of a particular item or the end item in the next period of time? So it could be any value. So highly for many items, particularly in the repetitive manufacturing and batch production scenario, you face this problem. So erratic demand pattern. So whenever you have this erratic demand pattern, now the mathematical modeling is very difficult. So the traditional approach for inventory control may not work. So for this particular, under these conditions, so you have no other alternative but to go for MRP and the similar to MRP or MRP like systems you have to implement. Is it okay? So this point is to be noted. So here the gross requirements what you find is more or less it's an erratic, say the demand pattern 5, 10, 18, 0, 10, 6, 0, 14. It may not follow any particular pattern. Now scheduled receipts, that is on the second period, it is known that there will be scheduled receipts of 20 units. So the projected on hand, that is 20. Now net requirements you have to calculate. You need to calculate the planned order receipts and you need to calculate the planned order releases. So the gross requirements is this one, 20 is the scheduled receipts in the second time period. So the projected on hand is 20. So obviously this will be your projected on hand after the gross requirement. This is 15. So 15 minus 10 plus 20 equals to 25. 25 minus 18, 7. 7, this is 0 gross requirements. So this remains 7. Then obviously this will be your 0. That means your gross requirements is 10 and you have projected on hand is 0. So what you need to do? That means your net requirements is 3. So the planned order receipts is what you try to do. That means now you consider the lead time and you planned order releases. That means you place an order for 3 units and after say the 2 time periods you get it supplied. That means the planned order receipts you are supposed to get it. That means the 3 units. And similarly in the next time period your requirement is 6 but you don't have any stock on hand. So you require your requirement is net requirement is 6 units. So what you try to do, you consider the lead time, you place an order, the planned order releases, that is the 6 units and you are supposed to get on 6. Is it okay? And similarly on the 7th time period you do not have any gross requirements, your projected on hand is 0. Whereas so you continue with 0 stock, and when you reach the 8th time period your gross requirement is 14. So you have a net requirement of 14 and this 14, that means the order receipts you have to make a plan. So the 2 weeks before or the 2 days before or the 2 time periods before you place an order of 14 units. So this way you create this table. Now the third example is for the MRP table below, indicate the project on hand, the planned order receipts and the planned order release. The lead time is 2 periods and the lot size is equal to 15 weeks. So again the same sort of data you have, like the gross requirements, the same set of values. The scheduled receipts is 20 and the projected the demand, that is the projected on hand, that is 20 units this stage, and you have to determine the net requirements, the planned order receipts and planned order releases. So the same procedure you follow, in fact you follow the logic one by one, and then you have these planned order receipts. So okay, this is just another example, and planned order releases based on say the lead time you compute. Now, with this, what we are proposing, that you should be familiar with this particular table. This is the basic table you have to create. Now, obviously, there will be many assumptions while you create such a table, but what is important is that at any point in time, the planned order receipts you must be able to calculate, and the planned order releases. Is it okay? So, this is the first level, and as the time changes, you need to recalculate all these the parameter values. Okay. So, I conclude these sessions. The two particular examples we have taken up, and the basic the procedures or the procedures we employ to calculate or to recalculate the values of all these parameters that we have explained. In the next lecture sessions, we will take up the other examples and other issues related to MRP systems. Thank you.